Working with ultracapacitors can be very dangerous. It's easy to cause harm to yourself, other people, or your property. How to build those ultracapacitors in a safer way. There's a lot of things that some of you may not know about ultracapacitors, things about the safety valves that's on these guys, that the shell is actually positive, not negative, things about the flammability of the wires that you are using to connect those ultracapacitors and how you can easily create a fire. People think, oh, these are going to explode and stuff. Yes, there is a chance of that, but the biggest issue is actually shorting them and fires. So we're going to spend some time working on those. Some extremely important things that very few of you guys know about, and I was shocked to know that, is that underneath this thin shell is a casing. And the casing is actually the positive. On this side, the casing is actually interrupted by a little barrier, and that's why you think these are connected, but they're not. So the negative is not connected to the shell, but the shell is positive. Why is that important? Because couple things. We often put those together and bolt them to a chassis that's metal, and if there's a little metal screw poking in the bottom or whatever, you're connecting the shell, the positive, to the negative. You're instantly shorting those, and we all know that shorting those guys is the worst thing that you can do. So just keep that in mind. The second thing, and I'm going to zoom in and to show you about these, is there is a safety valve on these, whether you know it or not. So here it is. I don't know if you could see it here. It's just a little flat surface, like a little small flat surface. I'm not sure if you see it on the skeleton one. If you can see it a little bit more because it's black. Here we go. Right here you could see it. So remember I told you these look identical? They are like, look at this, even the marking on the inside. They're pretty close to each other. So I don't know. I would say they're the same, but I cannot say that for sure. And so this is called the safety valve. And why is the safety valve important is for any reason you overcharge these, they get heated or whatever, the pressure, instead of this thing exploding, they made this safety valve. So this will actually open up and release all the pressure. So it's a better way to manage explosions. So whether you use two of these or two of these, always look for the safety valve and its location. And why is that important? Couple of things. You probably don't want the safety valve to be stuck straight down in the bottom. It might have a harder chance of exhausting. The second thing, you may not want it straight up into your face in case you're working or for some reason you're overcharging these capacitors. You don't want that puffing huge toxic gases and liquids into your face. And so you might want to put it, maybe I would suggest like a 45-degree angle, and you don't want it to be pointing to the other capacitor. So maybe like a 45-degree, or I would say more horizontal, or even slightly down is not a bad idea. Probably slightly down to horizontal, I would say. Avoid anything that's going to be shooting up, because you want to, later on we're going to put this in a case, you want to keep all these things maintained just in case. So we're preparing for any possible accidents. So second thing is you want to use I suggest you use the 3-volt ones. Like I said, for $10 more, you get that extra margin of safety that's going to really make a difference. If you're building a 3.3 volt one, I would go with a 2.7. It's not so bad. But I mean, again, you can still use a 3-volt one. But for 5-volt, now you're starting to creep up onto the margin of safety when you get a 2.7. It's easier. Okay, so next, what we're going to do here, we are going to try to get the wiring finished. Besides 2 wires, and you are supposed to basically put them one here, and then one here and one here, so they kind of go like that. The idea is great. The only thing I don't like are 2 things. I suggest you use the thickest wire you can get. And the next thing is You can either put them in the terminal screws here, which is not a bad idea, but if you want even better, you can solder them. And by soldering them, you're going to reduce basically the resistance between them. Remember, we'll talk about the fuse later, but do not remove the fuse or short the fuse here. This is one big safety you do not want to change. If you have something that's going to save you, it's going to be that fuse. Do not take it out. Don't listen to anybody that tells you to short this to save on some couple milliohms in ESR. You want to do that, get some better wires. So better wires to connect from here and actually solder them. So big and short. Big and short is what you want to do. You can use solid core. It's probably, I would say, more advisable. I have some silver wire I like to use. They're not solid core, but I like them. So before you use any of these wires, I want you to do this simple test. You grab yourself one of those little lighters, and you take the wire you're planning on using, and you subject your wires to this intense heat and count so many seconds. See, not much happened to it. This is a PTFE jacket wire. It's a silver plated wire that I like using. I'm not really endorsing this particular wire, but I'm trying to show you that the difference that what wires can do. Now we're gonna, instead of that wire, I'm gonna show you the one that comes in the kit that includes in that kit. Here we go. Look at that. So this thing is burning. Some wires will catch fire heavily and will burn very fast. And you gotta be careful with those because these are the worst. At least the one that comes in the kit by Ian stops burning once you stop subjecting it to the flame. So there's different levels of flammability of wires. So what is gonna happen if you are actually using those wires? Any short that's gonna happen, it's basically you're shorting the capacitors. And what's gonna happen is the wire is what's gonna get so hot and burn. And if the jacket of the wire is flammable, means you're gonna have a flame. Once you have a flame, you might be touching something else that's gonna burn as well, and before you know it, your house could be burning. So you want to use wires that do not burn. If you look at the code of what wires you put in, for example, inside walls, they have a rating for flammability. So you want to use things like that that don't burn. These wires, like we just mentioned, they will get hot, they kind of get soft, but they don't burn. You can buy those if you want, but there's other ones as well. I mean, I get probably, I'll put a link on eBay. I get a couple cents probably if you buy those wires, but who cares? Like really, it's not that much. I'm trying to get you guys safe. But get wires that, like I said, before you do that, test them. And that was one reason I didn't want you using those cables. They're like very inexpensive cables. So use that as a continuous output. But what happens if your clock or whatever you have here shorts? Basically, that wire is going to go in flame. And if that wire is close to something wood or something like that, that's going to catch fire. So if anything from this video you need to learn is how to avoid fires. Because you can touch those. 5 volt is not going to kill you. You can almost lick it if you want. Not that I advise you to do that. But touching those, this is not like high voltage. It's not going to do anything to you. But what's going to happen, there's so much power amperage in here that can melt things. This can melt like a whole piece of aluminum plate. So a wire like this is like nothing. This will go in flame in no time. So you want to, if anything I want you to learn from this video is use wires that don't burn. And some of these flammable wires, not only they start burning, they spread. So the fire starts running around. Before you know it, it's traveling all around different places. So be very, very careful. on these wires. So we are not going to use any of these wires in our system. We are going to use some very thick wires that are not flammable. I don't care what wire you use. All I ask you to do is get a torch, check it out. If it burns, don't use it. If it doesn't burn, you're good to go. Simple as that. And so we are going to solder one positive here and one negative here. So we're not going to use the terminals. We want to use actually the soldering pads, trying to reduce that resistance. Because remember, we want to keep the fuse. And that's another reason why you don't want to not use the fuse. Because if you don't have a fuse, and let's say you're using any kind of wire, and if the fuse is there and you short these, there's a chance the fuse will blow before these will start burning. So that's another layer of safety. So the importance of the fuse. Please, please do not take that fuse and short it right here. Do not short that. So again, layers and layers of safety hopefully will become safer. It's never safe, like I said before. No matter what you do, there's always a chance you can burn your house. So before we solder them, I'm just going to show you a quick thing here. These are very thick wires. I think like they're 11 gauge or something like that. So they're very, very substantial. The jacket is actually very thin, even though it doesn't burn. So what you want to do is just make a little Y here because there's too much wire. And when you put it in here, you basically want to feed the Y in. And this way you're going to have better connection because the nut that's going to fall onto it is going to go on each side. So I'm just going to zoom in on that a little bit. So here you could see there's a little Y one on each side, so we split it. And this way now when we tighten the screw, it's going to have a better connection. Of course, we're going to push it a little bit more. There you go, that's a bit better. And now you have a really, really good connection. You actually have a double connection. Remember, that's how we're going to reduce the SR on our wiring and compensate for removing, bypassing the fuse. All right, so here we go. I just soldered the two pads here, kept them really nice and clean. You see how I kept the wires as short as possible. So we have a nice soldered connection here, short wires, and we are as good as we can get. So some people might say, so okay, you've got, non-flammable wires, but what about those nylon zip ties you have? Are these gonna burn? Well, if you buy the right ones, they shouldn't. So let's take, for example, this one right here. If you put the torch again on it, as you can see, it's not burning. It's melting, smoking, but it's not creating a flame. You want something that doesn't just self-combust. You're never going to get the ideal material. These are not metal. Eventually, if you, as long as they don't keep burning, there's different levels. So you want to buy a zip tie that has flammability rating, and I'll put a link in the description below of one that is good. Sometimes they have a UL listing as well, so just make sure that they have some sort of a flammability rating, and don't trust anything. When you get them, do what I'm doing, put the light to it, does it burn or not? And that's the ultimate test. So another safety layer is we are going to cover those screws. Remember my very first video, I made a video that I stressed how importance of covering the screws, because if you have it somewhere and it butts onto something metal or another one, you're gonna short things because they're so prominent, they're hard, like they're easy accessible. You want them to be the least accessible as possible. So you can get what these are called cover screws. And they're kind of nice and handy. You just slide them on it and you're good to go. I found these on AliExpress. And actually, I didn't know that Ian sells them. I just realized now that he actually sells those, which is great because he kind of changed the size of the screws a tiny bit. Now these are a tiny bit loose. But what I like doing on top of these is I still like to use my trusty dandy electrical tape. So what I suggest you use, and we're just gonna go just like that. We're gonna go on the other side and we're just gonna cut it. We just need just one layer. And here we go. And here you just fold those like that, like so. And there you go. You got one safety layer. And on top of that, this is a positive, so we're going to put a red one on top of it. This makes it a little bit firmer as well, so they're not going to slide off too easily. And we're going to do, so see how much safer, another layer of safety. All right, so here you have it. So we've got all caps on. So what's left to do? We need to secure this. This should not be floating around. Let's say you have another one as well with it. You don't want them to be beside each other and somehow touching each other. That's why we have those caps. Actually, it helps. Everything helps. So, you know, this could fall, break, and wherever. You get your dog could come and grab onto it and starts running around with it. So you basically want to secure this. So what we're going to do is put a couple screws here and attach it to something. But there's other ways to do things as well. And this is when you want to ask yourself the question, where is this going to go? Ideally, you want to put these in a metal case. Have you ever bought a stereo system or an amplifier or a preamplifier or a DAC that actually comes on a plank of wood? Not really. They all come in a metal case for a reason, because they have to follow safety protocols. Now you can also, if you want to use this as a permanent fixture in some in a device that you're building, I suggest you got yourself a big metal case and put those in it. So for example, this is I believe it's a Hammond metal case that you can get off a Mauser. It actually goes kind of like this. It may not be ideal. You can get a deeper one probably. There's a couple of ways to do this. So you can have a metal case like this, and you could mount these just like that, so you can have up to 2 of them here, and you can have a slightly deeper case. The other option is you can actually mount the board here to the side if you want to keep it low profile. So you get a couple options. Another way of doing this, and so instead of using a metal case is probably your ideal, but this is the next best thing. So this is a case from Mauser. It's not cheap. It's almost $100. So you get, well, Canadian. So it's about probably $75 US. But it has a clear top, which is kind of nice. And what's really nice about it, this is not PVC. This is not going to burst in flames. These are UL certified. So these have great flammability, UL listed ratings. The base is actually UL 94.5 VA. And the lid is UL 94-0. You can Google those ratings. It gives you an idea what it is. What it is basically, if they put a flame on it for some amount of time, will it burn? And how long will it stay burning once you take the flame out of it? Kind of like the test we were doing with the wire that I just showed you, and how one of them burst in flame, the other one didn't. So these are pretty good for that. And what's nice, it's a plastic, you're less likely to short things there. And you can, I've searched a lot to get this particular, look how tight this just goes, nice. Just slides right beautifully right in there. And what you can do then, you can just attach a couple small screws here, and boom, you're actually, even if you don't attach it, it's actually pretty well in there. And so you can have it open if you want to, or you can still have it sealed as well. You can still see it, and you're less likely to have animals or anything, or basically your kids, or, you know, it's much safer. All we're trying to do, it's much safer. And that's one way. This one will house 2 ultracapacitors, so you can have, let's say, a +5 and -5 volt, and we're going to actually demonstrate that as well. So I'll put a link for this box from Mauser. This is not an affiliate link. I do not get any money from Mauser or anything, but there are things worth buying it's worth paying a little bit of money. I mean, you are paying $100 for one of each capacitor. So just, if you're going this far, spend the money and play safe and keep things in a safer way. Again, this is not the only way to do things. It's just another layer of safety. But if you are going to do this, don't buy the cheap PVC or ABS regular, the flammable ones. There's a version of this one which is more flammable, and you'll save probably $30, $40 on it. Yes, it's a lot cheaper, but is it worth it? Ask yourself that question. Like I said, we're all still learning and we're designing, so there is no final answer. We're not trying to claim any prize here. We're just trying to help each other work safer. It's all about those layers of safety, and the more layer of safety you can achieve, the better we will all be. I worry about some designs I see on the internet where they are tossed around loose, all the nuts showing. It's just a disaster ready to happen. And some people, they either know what they're doing, some people don't know what they're doing, but we all need to work a little safer because other people are following us. They watch what we do, they watch what's out there, and if we at least try to put something that's a little bit safer, at least we have achieved our goal. We could never think something is purely safe. I could never say that this is safe. The accident can still happen. I'm just trying to show you guys some layers of safety, but everyone has to work on their own and get their own layers of safety and do what they think is best, because after all, it's going to be your design and your responsibility. If you have ideas about how to put these things together in a better way or a different way of doing it, please comment below. If you have pictures, you can always put a link, or where your picture could be on a Google Drive or maybe on our DIY audio forum, just put a link to it. And the more people comment and the more we have ideas, the more we'll get a better picture and we can keep other people safer. I see a lot of DIYers, especially starting new, working with these ultracapacitors, and they still don't even know how to hook things even together. They don't even have the very basic knowledge. And I figure like, oh my God, they're gonna really get in big trouble or burn their house. So please be careful, and the more we can pull together to educate everyone and help them, the better we will be. I'm going to put a link in the corner on top here about how we are building this DDC streamer DAC. It's basically a very high-end streamer DAC by in Canada parts. And in the corner below, I'm going to put a link about 10 different songs you can listen to that's going to enhance your experience with your system. And there'll be a little speaker if you like to subscribe and help the channel. You can always help the channel by donating in Superbucks or even joining my Patreon. There's nothing on it, but it's just a gesture of support. It will help me keep buying all these things because nothing is really cheap. Things add up. I just spent like over $2,000 just a matter of few days. So, and again, I hope to see you again in another video. Take care and see you again.